So finally, my stupid computer is going to let me do part B in a separate video. So we're still talking about this guy doing a 100-meter race, only now the difference is he wants to do it in a total time of 10 seconds. So it's asking us what distance does he need to reach his maximum speed of 11 meters per second in order to have a total time of 10 seconds. So it's going to take him some time to go through to accelerate through this distance to 11 meters per second. And then if the total distance is still 100, because it's a 100-meter dash, then for this chunk, this would be 100 minus delta x. And for this chunk, since the total time is t, or 10, then we would do 10 minus t. And here, acceleration, of course, is going to be 0. So there's a crap ton of unknowns here. But with Algebra 1, we can do it. I'm going to write down the acceleration equation, since this is constant acceleration. So I'm just going to plug in some numbers. The first equation I think of is A equals VF minus VI over T, or delta V over delta T. Here A, I don't know, equals my VF minus VI, 11 minus 0 is 11, over T. I don't know. So that's all I can write with that equation. Second equation, I'm going to do delta x equals 1/2 a t squared. Yay, I don't know anything in that equation, so I'm going to hope that I'm not going to use it. The other equation would be VF squared, or 11 squared, equals VI squared, or 0, plus 2a delta x. Okay, so I have three equations here. The equation for this side, there's only one, because it's constant velocity. There is no acceleration, so the only equation we can look at is displacement equals velocity times time. So my displacement is going to be 100 minus delta x equals 11 times my time, which is 10 minus t. So here I have four equations, but three unknown variables. So this is great. I just need to pick three equations and use substitution some number of times to ultimately solve for delta x. So what I'm going to do is I'm going to use these equations to solve for t, so I can get rid of it in this one and solve for delta x. So this is pretty easy. If I do 11 squared equals 2a delta x, then I can plug in 11 over t for a and solve for t. So that's what I'm going to do. 11 squared, let me get where y'all can see this. 11 squared equals 2a, and we know that a is also 11 over t times delta x. So this is good. This 11 cancels with that 11. T goes over here, 11 comes down here, so t equals 2 delta x over 11. Now I'm going to plug this in here. So 100 minus delta x equals 11 times 10 minus t, which is 2 delta x over 11. Okay, now you guys have done this like in 8th grade or 9th grade, whenever you took Algebra 1. The only problem is when you're a little freshman, they don't give you problems like this as practice, because then you'd probably cry. But it's all it is. It's just substitution like a million different times. I need to distribute that, so I get 110, that 11 cancels. Now we have a beautiful equation. Subtract 100, you get 10, add 2x, you get 1 delta x, and so voila, our answer is 10 meters. That means he needs to reach 11 meters per second and 10 meters in order to do this race in 10 seconds.